All right, so we just learned about the relationship between radicals and rational exponents. Remember that any radical, something written maybe like this, the hth root of x to the nth power can be converted into a rational exponent, something that would look like this, x to the m over h power. So you can go back and forth from radicals to exponents and exponents to radicals. So what we're going to be doing now is just extending our knowledge of radicals and rational exponents by applying some of the laws of exponents. Now, the laws of exponents is something that you would have learned back in Algebra 1, so I just want to go through a very quick, brief review of what these laws look like and why they work. So the very first one is product rule. Product means multiply. So for example, if you had x squared times x cubed, what that actually looks like, x squared would be x times x, and then x cubed would be x times x times x. And if you're multiplying those together, how many x's do you have? This would be x to the fifth power. So the rule that we say here, if you notice the exponents, x squared times x cubed is x to the fifth. All you have to do is add those exponents together. So if you have any type of multiplication problem, all you're going to do is add those exponents together. So I'm going to make a note here, add the exponents. Okay, power rule. Power has to do with an exponent raised to another exponent. So you have a power to a power. So something like this, x squared to the third power. So x squared to the third power would be x squared, x times x, 3 times. So x times x times x times x times x times x. So you have x squared times itself 3 times. Now if you notice, that's 1, 2, 3, 4, 5, 6 x's. So this would just be x to the 6th power. Now without having to write that out every single time, what we see is if you have x squared to the third power equals x to the 6th power, all you're doing is multiplying those exponents together. So if you have a power to a power, you're just going to multiply those exponents. So make a little note here. All I'm going to do is multiply the exponents. Okay. Rule number 3 is referred to as the quotient rule. Quotient means divide. So here we have x cubed divided by x squared. So x cubed would be x times x times x. X squared would be x times x on the bottom. And we know that anything divided by itself is 1. So x divided by x is 1. That cancels out. Another x over x is 1. That cancels out. All we're left with is just one single x up there on top. And you can guess how we get there. If you have x cubed divided by x squared, 3 minus 2 is 1. All you're doing is taking those exponents and subtracting them. So if you have a division problem, all you do is subtract the exponents. Now, sometimes when you subtract the exponents, you might end up with a negative. So I want to indicate what that looks like. So here in this example, we have really the same thing as before. It's just switched. We have x squared divided by x cubed. And if we follow the rule of subtracting, we know that 2 minus 3 would give us a negative 1. Well, what does that even mean? What does that look like? So let's draw this one out. X squared on top would be x times x, and x cubed on the bottom would be x times x times x. And again, we go through the process. Anything divided by itself is 1, so that cancels out. Again, you have another x over x is 1, that cancels out. Again, we're left with 1x, but notice that x is on the bottom. There's nothing left on top, but remember that we divided these things, and as they cancel out, anything divided by itself is 1. Okay, so what that means, when you subtract and you end up with a negative exponent, all that means is that the x is left on the bottom. Okay, so for example, if you ended up with x to the negative 2nd power, really that's just x squared. The negative tells you that it's on the bottom. Okay, if you had like x to the negative 5th power, that's really just x to the 5th power. The negative tells you that it's in the denominator. Okay, so if you ever end up with a negative exponent, just move it on down to the bottom. All right, so let's apply some of these laws of exponents. Okay, so here we have the fifth root of x to the seventh power times the fourth root of x to the third power. So here I recognize, first of all, that this is a multiplication problem. And I know that if you have a multiplication problem, you are supposed to add the exponents. Okay, so we need to add the exponents. The only problem is I don't see exponents, I see radicals. I'm going to convert this first into a rational exponent, and then we're going to go through and we're going to add the exponents like it says to do in our law. So remember, the man rides the horse, the man is in the house, the horse is outside. So this would be 7/5, x to the 7/5 power. And over here, the man rides the horse, this would be x to the 3/4 power. Now I see exponents, and again, with a multiplication problem, what we're going to do is we're going to come over here and we are just going to add those exponents together. 7/5 plus 3/4. Now, you could do this very quickly with a calculator. I don't have a calculator with me handy, so what I have to do is get a common denominator. Let's see, here I have a 5, here I have a 4. So on the left side, I'm going to multiply by 4, and on the right side, I'm going to multiply by 5. That would make this 4 times 7, that's 28 over 20. On the right-hand side, I have 3 times 5, that would be 15 over 20. So if I add those together, 28 plus 15 is actually 43 over 20. So my answer would be x to the 43 over 20 power, if I leave it as an exponent. If I want to put it back to a radical, remember the man rides the horse, the man goes inside, the horse stays outside. So your final answer could be written either way there. All right, so this one is one that usually is difficult for people because you look at this and you're like, whoa, I've never seen anything like that. We have a root next to another root. So if I'm reading this, what I see first, I see the square root of the cube root of x to the 8th power. Okay, so let me break that down a little bit. This part in the center, I'm just going to leave that the same for a second, and I want to deal with the outside. So the outside is just this square root. And I know the exponent for a square root is 1/2. Every time you see a square root, all that is 1/2 power. Okay, so now I can convert the inside to a fraction also. This one, we would have x to the 8/3 power, right? Because the man rides the horse, the man is in the house, the horse is outside. So really, all this is a power to a power. And if you have a power raised to another power, all you have to do is multiply those exponents. So here, I just need to do the math. I need to multiply the exponents. This is going to be 8/3 times 1/2. So I'm going straight across here. When you multiply fractions, you go straight across. 8 times 1 would be 8. 3 times 2 is 6. This can be simplified a little bit. 8 over 6, everything's divisible by 2. So if I simplify my fraction, that would be 4/3. All right, so my final answer when I simplify this would be x to the 4/3 power, or as a radical, the man rides the horse, the man goes inside, the horse stays outside. So it could be written as the cube root of x to the 4th power. Either way, this would be your answer. All right, next up, we've got a division problem here. So we know that on a division problem, all you have to do is subtract the exponents. So we need to write this thing, instead of writing it as a radical, we want to write it as an exponent. And all we have to do for division is subtract those exponents. All right, so up top, let's see, up top, this is the square root of x cubed The man rides the horse. Okay, on the bottom, there's one x in there. So if I want to change this to an exponent, that would be x to the 1/4 power. And all we need to do is subtract those exponents. So 3/2 minus 1/4. You can use a calculator for this step, or we can very quickly get a common denominator. The 2, I need to multiply by something so that I could end up with a 4. So all I really need to do over here is multiply by a 2. So up top, 2 times 3 would be 6/4 minus 1/4 equals 5/4. So my answer would be x to the 5/4 power, or I can put it back into a radical, which would be the 4th root of x to the 5th power. All right, one last problem, applying the laws of exponents. We've got the cube root of 27x cubed y to the 12th times the square root of 81x to the 6th y to the 10th. Now, this is actually a pretty challenging problem. We're just going to take this in parts. So I am going to focus on this first part right here, and I am going to write that radical as an exponent. So the part under the root, that one's going to stay the same, 27x cubed y to the 12th, but this is the cube root. Cube root is the, and essentially what I want to do, if you have a power to a power, right, if you have a power raised to another power, all you do is multiply the exponents. So that's exactly what I want to do here, is I want to go through and I want to multiply all of the exponents. Okay, so I see an exponent for x. Do you see an exponent for the 27? It would just be a 1. So if I go through and I multiply all of the exponents, this would be 1 times 1/3 would be 27 to the 1/3 power. 3 times 1/3, third of 3 is 1. And 12 times 1/3, a third of 12 is 4. Okay, so we've broken this part down. And one thing you can do here is type this into your calculator, 27 to the 1/3 power. That's a number. You can actually calculate that. 27 to the 1/3 power is 3. So 3x y to the 4th power. Okay, so we've dealt with that first radical and we've simplified it as much as we possibly can. Now we're going to go through and we're going to do the exact same thing with the other radical. So I'm going to start by writing it as an exponent. So inside I have 81x to the 6th y to the 10th, but this one is a square root. Square root can be written as a 1/2 power. So cube root is 1/3 power, square root is 1/2 power. Okay, and what we're going to do, now we have a power to a power, we're just going to go through and multiply those exponents. So on the y, my exponent is a 10. On the x, my exponent is a 6. The 81, you can write in an exponent. We're just going to go through and we're going to distribute that exponent to each one. So half of 1 would be 1/2, so 81 to the 1/2 power. Half of 6 would be 3, so x to the 3rd power. And half of 10 would be 5, so y to the 5th power. Now you've got a number here, 81 to the 1/2 power. You can type that in your calculator. 81 to the 1/2 power is 9. So you've got 9x cubed y to the 5th. Now remember that this was a multiplication problem. So when you get to this step right here and you're trying to multiply, remember that when you multiply, you add the exponents together. Now, the 3 and the 9 are not exponents. 3 times 9 is 27. But when you look at the x's, x times x cubed would be x to the 4th power. And when you look at the y's, y to the 4th power times y to the 5th power would be y to the 9th power. And that, my friends, is our final answer.